Okay, guys. Hi. I just wanted to give you guys some visibility into like what I'm doing, what the approach is, what are the benefits, what the heck am I even doing? I thought I'd do this explainer video. I just made this today, so I'm sure it's pretty rough, and there's things that I need to improve with it. But hopefully, this gives you some ideas or some context about how to ask questions for clarification, etc. I'm just calling whatever this is Keiken V. Uh, there's a history behind that, but it's not important. So I'll just jump right in. Let's see if I can move forward. Is through this thing is just basically what is my philosophy? Why am I so stoked about ML ops and Google Vertex in general? I'm going to show you how I've actually applied this Google Vertex as a practical example. And then I'm going to show you some other experiments and use cases. So let's go start. So first of all, why do I have any perspective on AI? I am not an AI expert. I have only been really a consumer of AI research. I try to apply it in practical ways. Clients have been asking for these things for solutions. They don't know how to implement them. They don't have the proper process or internal rigor to even really tackle it. So, I've been around in the consulting game for many years. A lot of my experience has been in the IoT space. A lot of the data coming from those sensors or signals, I tend to call them signals, just generates volumes of data. And very often the analysis that's being done on it right now is poor. I've had experience with Azure and Google Cloud directly in trying to resolve some of these problems, trying to make better decisions, and B, how do you make that scalable, and how do you make that real time? So, over my years dealing with clients, I've also used my own personal pet projects. I've always done this to really push the envelope on what I can do and use those as essentially a playground for really sort of what I would consider undiscovered technology to me. Let's just put it that way. And so, when I look back over my career, one of the interesting projects that I first created was fantasy football for Windows. And back then, when you were trying to, early on, it was the product was pretty static. Here's a bunch of data. You pick your own lineup. There was no trying to guesstimate what performance would be, what your proper lineups are, etc. Now, the big problem with that was not that there was no technology that could do that. And that is not the issue. The issue was that the data that you're getting from the NFL at the time was incomplete. It was inconsistent. And the reality of the situation is that the data was so dirty that you couldn't really effectively build any sort of decision tree that would work, hold through the test of time, and as data and seasons are changing, and actually be of any use. So that was there was some efforts in using some ML back in those, but it was just so immature that it was just, it was a frustrating experience overall, but a great learning experience. Later on in my career, I worked with the University of Alberta, and they were doing a cutting edge poker AI program. And what I find fascinating about poker, as opposed to like chess is essentially just a big giant dictionary. Poker is a dictionary of experiences that you use to inform how you will best guess what you don't know about the problem space that you're currently working. So for example, let me put that in practical terms. So in poker, I don't know much about my opponent necessarily. I've only observed his behaviors. Is he a tight player? Is he a shark? We may not even know. But given what I do know, what kind of statistical probabilities can I assign, or what kind of personality can I assign to that person? And given that, what actions can I take, given the understanding of who that player probably is, in order to get a desired outcome? In poker, of course, it's to win the most money. And so, against tight players, you might slow play. Against aggressive players, you might go all in. There's a bunch of different variety of play styles. And the reality is those play styles, in order to be really good at poker, those play styles have to change throughout the game and have to change based on the opponents at the table and the nature of those opponents, et cetera, et cetera. So ultimately, you're not playing the game, you're playing the opponent. And, there's some amazing work that was done back then in order to essentially tiptoe into machine learning and game theory that I can describe later. Anyway, I have a perspective. I know some of the problems, and really the biggest problem is incomplete data. Most organizations don't have their data collected in a single place. Performant, meaning that it's in a data lake, and it's labeled, it's described well, so that it can be consumed by any of these new emerging services. So let's go ahead and move on. Okay, so in order to sort of fix some of these problems and the huge data and jagged or incomplete data, there's different ways of approximating what that data could be, and then forward to feed that into other models. Biggest problem is, very few people know how to do this. Very difficult for them to share their knowledge. They're difficult to get right. They're difficult to understand why results are changing over time as new data or new signals or new sensors are added. And even ones that have been successfully implemented are so generic and are so brittle that they just don't evolve. You can't ask them specific questions about your business because they're modeled off of public data, huge sets of public data, which is super useful, but generally no data that's really specific to your business and your domain, your customers, etc. And so, you'll see a lot of ML efforts fail, right? So these are problems we have to fix in order for machine learning to take off and for people to really understand how it's going to benefit whatever they're trying to do. Cool. What DevOps has done for development, gone are the Wild West. We have ways of measuring progress. We have ways of holding people accountable. It's just a generally a better deployment mechanism, a complete continuous integration, continuous delivery pipeline. So Google has done that for machine learning. I'll call it ML Ops from now on. It's going to be the buzzword. Get on the bandwagon. Google has Vertex is really just an ecosystem, a set of tools, best practices, and infrastructure on their side that represents really the best of breed right now. And I am impressed. The stuff that you have, even the stuff I've implemented previously on some of the stuff I'm about to show you was dramatically easier with Vertex. Man, what I could have done eons ago with this in my back pocket, it is a game changer. Early on, if you talked to me 10 years ago, I was data is king, right? It is all about big data. Well, the reality is that problem has been solved. A lot of enterprises may not be there yet, but that there is best practices. There are known solutions about how to achieve that. And the reality is, a lot of people don't even know what to do with their big data. And so again, this is where machine learning helps. And, models that you develop essentially become SMEs about your SMEs on your business. And, that model, the practical application of that model is the future of your business, is how you will compete. Okay, so in the real world, ML solutions require a network, a graph of different models that feed into each other. You might ask one model, to identify something in pictures. You might ask one model to extract the sentiment or meaning out of, audio clips. All of these can potentially feed into each other and affect each other. These models, are trained not only based on your data, but can be combined with public data so that you can basically take advantage of all the learnings that some of these big enterprises like Google have put into maintaining these data repos. So, you can take their existing data, even their existing models, and use those as baselines to, evolve your internal models based on leveraging your own internal customer, or not customer data, but your own internal operations data as well, right? So whatever that data is that you're deciding on. So this is game changing, right? The other thing is as you're adapting these models and training these models, often, they'll behave in very unpredictable results, or very unpredictably with unpredictable results. And sometimes it's very difficult to debug, determine what's causing such variations or skew in your model results. And, you're really beholden to, resources that really know what they're doing and may not even have some best practices in place. And again, just returning back to how brittle most of this infrastructure is and most of these homegrown implementations, even once you do get them up and running, they're not really evolving with up-to-date data and changes. And so they don't flex. What I mean by flexing is, they don't respond well to, seasonal behavioral changes. What happens if you have a model that's based on 10 years of data and something has drastically changed over the last year? COVID's a great example. This really blew the doors off of most models. Then, the other thing is, once you are well down the route of developing your own internal models, you have to be able to measure whether they're effective, be able to deploy them easily, be able to roll them back easily, be able to share those with whether they're internal to your enterprise, or you can even make them public to the general public at large to utilize and chain or leverage into their dependency graph of other models. So it just gives you immense flexibility. If I add some additional data or features to a model, like, hey, for example, I want to incorporate age as a data point in some of my forecasting, that can completely destroy the model, and I want to be able to back those changes out, or I want to be able to test those changes against a limited set of users. I want to be able to compare against previous versions of the models. And I even want, as I iterate over different models and make improvements, or potentially try to make improvements, I even want the system itself to look at the model changes and tell me in a very visual and easy way what's changed, why it's changed, and even offer potential suggestions. It's amazing. I think I've already insinuated this, but what if scenarios, being able to add additional data and see if it actually moves the needle in an interesting way is what this science is all about, in my opinion. All right, let's keep going. All right, so I'm going to start moving into a practical example. It's very important. I picked this example because it's a great demonstration. It's a practical passion, or it's a passion of mine, and in reality, it demonstrates a lot of the fundamental principles that will work across the board for many solutions. As a matter of fact, most of the underlying infrastructure in here can be repurposed and is repurposed for things like, which will be particularly interesting to people listening to this, is like sentiment analysis of natural language processing and dialogue and those sorts of things. Data is data. There is patterns in all data, and models recognize patterns in data, no matter whether it's a picture, voice, financial data, etc. So I'm choosing 360 video. It's really the stretch goal. It's the hardest, in my opinion, one of the hardest problems to solve. It's vast amount of data. You've got low resolution relatively to a lot of data or video sources out there. Because of the nature of it, it's got really high noise and differing shuttering speeds throughout flight. So it's very difficult to compare that video or interpret that video in the same way consistently every time. This is true for all data in general. And so one of the first things that you have to do is you have to normalize that data, and we'll go through that, what that looks like. All of these demos that I'll show you all leverage facial recognition, gesture recognition, voice recognition. All of these things are incorporated into this, although because it's really loud, because it's on a drone, it doesn't really take advantage of those things. So, I'll have to show a different demonstration on that. But because this is built in a very scalable and microservice way, these are very performance systems. And the stretch goal here is to do all of this functionality, all this I'm trying to demonstrate in real time. Now, there are some challenges to that, and I'll kind of talk on that here in a little bit. So let's go ahead and show you a demo here. Okay, you got to throw this in. Not only going to put a 360 video, I'm going to put it on my drone. We're going to fly it fast, and we're going to see if it can keep up. I didn't even know if this thing could fly. I just did this yesterday morning. Here we are. It flies. All right, so if you've never seen a 360 camera before, a 360 camera captures a panorama essentially in all directions. Here's the first frame of this. You'll see that, this, if I join this edge, if I wrap this around and join this one, it would make a full picture. So this particular drone, as you saw in that previous picture, has 4 props. 1, 2, 3, 4. You can see that. As a matter of fact, pay attention on this video. You'll see me walk here, and you'll see me walk out this frame, and I think back into this frame. So this is just further evidence that this is like just a big 360 panorama. Now, it doesn't do anybody really any good. A lot of people, the consumer market for 360 isn't really active, except in the enterprise and industrial areas, just because what are you going to do with this? It's not great footage. You're going to wear a VR helmet or not a VR helmet, but you're going to go into VR to look at this, or you're going to have to reframe it. So let's go ahead and take a quick. Now, let me just make sure that you understand, okay? I am flying this drone. I am not controlling a camera. I am not doing anything. I am flying it around. All of the content that you see downstream from this or further in this deck is all based on this one single video. Okay, so this is the source. So let's just go ahead and let you take a quick look at this. Thank goodness I turned down the sound, because the props on this are really loud, especially with this being mounted. So this was, made me pretty nervous. Here's where I think you'll see me coming out the left-hand side. You see, right? Up here, back in and out. But anyway, it is possible to extract regular looking video and pictures out of this, but it takes some perspective morphing. You have to understand where you want to look, what the frame size is, all of these challenges. So I'll go ahead and let this play out in full. Just the first time, because this is as I mentioned, the comprehensive flight. Okay, so you get an idea. Not very useful, interesting, okay? Oops. Okay, so we have that data. Yes, you can view it in VR, not super useful. So, what we have to, since we want to actually run models and get useful information out of this, what we have to do is we have to normalize our data. This is true for any kind of data. I have some examples up here. I have, here's some monthly data, and there's some missing, right? Traditional linear thinking, you'll approximate what that value is and add it. Let's say, for example, if I'm trying to upscale an image, so let me take a step back. In order to normalize this 360 video processing, what I really need to do is to convert it into normal video that that image recognition models can know how to deal with. So it needs to have enough pixels, and it needs to be in a flat perspective that these models have been trained to recognize. So we have to basically flatten this 360 video. In order to flatten that, we need to change its perspective, and we also need to double its size, okay? And just when you double its size, it's just as if you were like taking every other pixel away. Well, you can approximate that by doing linear, like, okay, if there's a green here on this pixel and there's a green there must be a green in the middle. If October was 30 and December was 3.2, then the middle must be, exactly between that. Or November must be exactly between that. We know that in practice, that is just simply not true. And so what these models do is they basically take a source this model is learned from a bunch of existing examples that have a bias, confirm, or deny is not the right word, but confirm, a model's assertions, right? Which will ultimately reflect its accuracy. But anyway, what I'm trying to get at is that instead of inferring a value here or inferring what a pixel color will be, it will actually use all of this example data, historical data that it's looked at to approximate or to actually guess what that pixel looks like. So this principle, everything that I've done here is all well-defined and in practice and in production and used and rock solid, frankly. So let me show you a difference. If you just did a scale up and just interpolated the data using this standard linear regression, you're not going to get interesting results. Where you start to get interesting results, and this is based on research that, here's a great neural model. This is the same neural model that I'm using to enhance our imaging. Let's show you like an original old-timey photo or video. We've already done some cleaning up and stabilization, I can tell, right? But, given an old photo and given new content, or old video and new video, and letting the model train on that, we can then apply the results of that model to interpolate missing content, whether that's pixels or scratches or even shakiness where it has to compose borders. It's even colored it, as you can see. Right? So this is all the rage right now. This is it went viral where people were actually like, updating old-timey photos. Okay, anyway, let's just kind of show you how that's utilized here. You can see on the left is the old data. That's, this would be if it's doubled and interpolated. You can see how grainy it is. You can see the definition of the bench here. It's just not there. It's unusable for doing any sort of image recognition. here you see a neural model that's applied. And yes, there's some artifacts here that probably can be cleaned up, and these models can be trained and improved over time. But you can see the clarity of the bench. You know, there's some, I didn't want to include another screenshot, but there's been a perspective morph on this. So it looks like a regular shot, etc. Anyway, done, processed, and now that can be fed into, you know, the downstream image recognition, object recognition, those sorts of things. Okay, so what does that all do for us? So once we, oh gosh, I don't even know how to click for it. Okay, so once that flattens and adds perspective and scales up to 4K into a common color space and resolution that all of these image recognition and models are trained to utilize, we're in business. So here are 4 examples of points of interest. So these are items that it has identified, the model has identified as interesting, and has created a bunch of short clips. As a matter of fact, from that one source of data, there was approximately 1,000 clips generated from this. And here are some of the more interesting clips, I guess. You know, right now, currently, that's what it's ranking is more interesting clips, okay? Now, these are just, you know, by themselves, living by themselves. Let's take a quick look. All right, here's Travis. Notice how it's okay, whatever, dork. It's reframed it. Here's Charlie, the blonde dog. Again, this is all from that same source that you saw. So it's tracking her. Let's take a look at Barkley. Awesome. Okay, good. Okay. I guess there's some benefit there. Look at that, goes on for quite a while. Okay, so then here, I don't even know why it picked the drone. This is something that I'd have to look at the model and basically say, yep, this is of interest, or no, I'm not interested in filming myself. Okay, cool. So now I have a bunch of content that I have now identified, and now I can actually compose that content, construct it into, you know, a clip, or, you know, construct the most interesting clips that are most interesting to me into videos. Now, in this case, this particular model that I used to generate this, I had a particular interest in myself, Travis, because my face is registered, and other aspects of me are registered. Just basically everything about me is registered. And then also my dogs are registered, right? So it knows when I compose these videos, or when I asked it to compose these videos, it looked through all those thousands of clips and it said, these are the clips that I believe are the most relevant to you. Most interesting, relevant to you is probably, might be a better way to say it. So I asked it to create me a 10-second clip. Here's what it generated. Okay, let's do a 20-second clip. So this is automatically generated. I asked it to generate it. It picked the in and out points. Decided length of clip. Now, all these things, you know, have variability and are getting tuned over time. So none of this is really perfect. Like I wouldn't have put this in there, but you know, okay, that gets tuned, whatever. So you can see, all right, you know, now the time frame is irrelevant, you know, as long as you have enough content, right? I can't ask for 2 hours if I have 30 minutes of content. Maybe. It's not necessarily true, actually. But, you know, yeah, there's a number of use cases and where the number of seconds or the time that you want to fit into is useful. Anyway, let's go ahead and move on. Now let's take the use case. So that generated something interesting. Okay, cool. All right, now we also have full image recognition, object recognition that is occurred throughout that entire video. So it is also composing those clips based on what I've identified as my own personal interests, or what it guesses could be my own personal interests, or what is interest to the general public if the model isn't trained in my particular customer base yet, or user base. But so I asked the model to generate me another video, but in that case, I weighted the model to say that I was interested in overlake and owls. Okay, and so it's done. Here are some of the things that it knows out of this scene: text, grass, outdoor sign, bench, overlake, owls. And so it knows. Now I've asked that same model, with my interest being overlake and owls, to generate a video, and here's what it generated. It does a weird zooming out. It does some of this stuff. I wouldn't necessarily do all this stuff, but that's stuff that can be refined and cleaned up over time. But you see it like completely reframed everything with overlake owls in it, with a bench in it. And I can even do, like a TikTok sort of representation, with all auto tagged and, all that sort of stuff. It's totally available once I have all of this stuff classified and recognized. Okay, so we have two different streams of two different content from the same source already, with different interest levels feeding those models. Now you saw it reassemble a bunch of content based on clips that it had classified. Once it's understood my needs, I can also say, hey, don't cut up the original content. Just go ahead and do a bunch of automatic reframing. So let's go ahead and execute that video again with owls and benches as this user's particular interest. Let's see what happens. All right, it's got me. It doesn't see any owls or benches, so it's not oriented towards that yet. It sees my dogs, sees both dogs, as a matter of fact. That gives it a high interest level. Okay, now zooming in, because now it has all three. Okay, now we're seeing significant movement. Now it recognizes owls and bench and orients the framing and camera towards that. Zooms out, as you saw earlier. Senses movement going back the other direction. This is exciting. All right, cool. Reframes me and the dogs again. Comes around this way. Oh, okay, it sees a tree. It thinks trees are interesting. Okay. Here's my bench. Here's my owls. Tree, bench, owls. Right? Okay, so that was all informed by object recognition and image recognition techniques. And then that fed the reframing of the entire 360 content. So anyway, you can start to see the flexibility that you can get with this. Again, it's not that I think that this is amazingly useful necessarily, but I think it really stretches its capabilities. So let's take. Okay, so let's look at another case, right? So, that one was not a great demonstration of gesture recognition, natural language processing, and sentiment. Here is a video that was shot on one 360 camera. And based on that single source, it then went through and cut this up and automatically switched between, different members of my family based on who was talking or emoting the most. Let's see what it did.
This is a great jacket. Definitely kind of jacket.
Yeah. Well,
Yeah, cut over to me because I was talking,
like,
something.
too big that he'll grow into.
I don't think it's gonna be. I think
All
it's
right.
maybe like he needs to go just a tad, and I think.
Okay, so I had no influence over it cutting back and forth. You know,
Yeah,
It's a little big,
It's
but
a
not.
little big, but,
But
it
you're
looks
still,
good.
you're gonna. I'd
Some
rather
framing
do like
issues.
that than too small.
yeah.
all things that can be fixed and trained out of this thing,
Of course not.
right? Okay, interesting. So that was, and you know, also be, yes, all of this stuff is, even this happy birthday in the background is OCR'd. All the text is processed and sentiment captured. That is all being done. You know, as much data that can be extracted out of this stuff, I'm extracting. More data, the better. I did want to show you something that I think is really cool. So one of the things in, the stretch goal of this is to process this all in live. So let's say, for example, I had 4 360 degree cameras in a, let's say at a sports event. It's very common for a production crew to have what they call a multicam control panel and video feeds. And so they'll see something like this, right? You know, where it's like, okay, here's 1 camera, here's 2 camera, here's 3 camera, here's 4th camera. Except in those kind of situations, they'll have many, many more. And then it's the job of them to essentially, pick which source they actually want to throw on the live feed. Now, the interesting part here is these feeds are actually coming from the cloud. And it is, these are all appear as virtual cameras to, in this case, Premiere Pro, right? So it's not live in this case, but this could easily be done live. These could all be video sources coming from traditional video sources, or multiplexed, meaning multiple streams are generated, intelligent streams, like I was just showing you, from one 360 degree camera or many more, right? So there's virtually no limit. And let me show you kind of what that looks like. So if I didn't want it to auto switch, I could also just use, your standard input panel. And why is this useful? Well, if I have 30 feeds coming in, or I have a 360 camera that it's generating 6 to 8 feeds itself, I want those prioritized, right? I don't want all 30 presented to me. I want the top 4 presented to me. What has the most, interest, for lack of a better term, right? Whether it's motion, emotion, gestures, all those sorts of things. I want to see those escalate to the top so I can pick from the best. There's all kinds of clever things that you can do also. I can even cause, frame these with to ensure that certain things are in the background. So let's say, for example, I wanted to ensure that I'm framing 2 people at least, right? I can establish some weighting, some preferences like that. So anyway, I don't know if that makes any sense, but very, very cool and practical in the production world. Okay, so another thing I want to show you really quick is, the big problem with existing models is that they're so brittle. The introduction of new data can corrupt or skew your model so horribly that they're not practical. And so, a lot of existing implementations are really hesitant about adding new data streams and adding new sensor information to whatever decisions they're making. And it just can't be that way, right? You need to be able to handle new data in an elegant way, and data that is corrupted and missing at times. And so, again, Vertex helps mitigate that. Because it helps mitigate that, there is no fear to add as much processing instrumentation as you can. And as we're starting to get more real timey, there's a lot of value in pushing those decisions and pushing that processing to the edge, to the actual devices themselves, and not merely rely on cloud processing to do all of that. So, I want to just point out there's a little device sitting on top of this camera. So this is a viable film camera. On top of this is what I believe is the most sophisticated, small, low energy form factor ML device made right now. Not only does it have TensorFlow and GPU acceleration contained in it for executing models at incredible speed, but it also has LiDAR and multiple cameras on it, so that it has a parallax effect. What that helps with is established depth and increases accuracy. Net sum of that is that it unlocks on the device itself the ability to do things like OCR, object tracking, facial recognition, emotion recognition, and that is all done on the device and actually embedded and synchronized with the actual filming, if you are doing any filming. Really, really cool. The combination of also that device has things like gyroscope. And so what ultimately the point being is that it knows where it is in space at all times, and therefore whatever it is attached to, it knows where it is in space at all time. The trick, the value there is that, when you're filming with this thing, it then can take in all that information and tie that essentially to that footage, that metadata to that footage. And that can help from a speed and also accuracy perspective, speed things up, make more real time. So, one of the other things that device does is, it allows you to do depth sensing and actually render your object, or render the observable world in as a model itself. So let me show you how that kind of works. Now I'm demonstrating on a phone here, or I'm having my wife demonstrate on a phone right now, but this device sitting on top of this does the exact same thing. This is just way easier to visualize. So I'm going to show you how you do a scan.
It's just okay, yeah. And you're going to scan it up and down.
I don't need to. Okay. So, the new iPhones actually have LiDAR built in. So these are actually firing the same sort of lasers that come out of this device here. And it's essentially building, as you can see, it's now well, you can't see it very well. Let me show you what it looks like over here. That's what my wife just captured. Now, it wasn't a very good capture because she just did it really quickly. You saw it, you feel it. So it doesn't get everything, but you can see it's a fully interactive model. It allows you to rotate, basically allows you to describe in very accurate terms your entire 3D physical world that this exists in. So, let's look at something else that's interesting. So this is a device that is computer controlled and is integrated with output coming from that same device that was on top of the other camera. It's doing LiDAR scans of this area, and it will constantly repeat and do this over and over and over, and will fill in details and move as necessary. Why is this necessary? What is this for, right? Even though there is, multiple cameras on this thing that are offset by a couple of inches, that creates a parallax effect, which allows you to get depth sensing. The more parallax you get with this movement side to side increases the accuracy, as well as it's automated, right? So in a use case that I'll talk about here shortly, a high degree of accuracy is required, ongoing accuracy, of the environment. And so this thing will constantly be running all the time. Whenever there's any uncertainty, it will move and observe that area that has uncertainty. And really what this does is it takes snapshots of like this all the time. And so not only can it visually inspect for changes, but it also has a full 3D model that gives you abilities to detect different types of changes, as well as doing volumetric estimation and all kinds of other really cool stuff that you can do. Of course, you don't need any of this to get halfway there. Putting this little device on your desk, if you're doing your own sort of podcast or something where, you wanted to produce clips of, highlights of your show, put it on your desk and point it at you. You're probably waiting, your facial expressions mostly in the content of what you're saying mostly anyway, so who cares? But, in movie production where, the details matter, accuracy is needed. And so that's where the expense and maintenance and operation of one of these things makes it worth it. So really, again, it's just like, juices you get to pick your poison. I kind of mentioned, oh shoot. What is that kind of like, what is the other application of this that I'm targeting? So I kind of hinted at this, but this is being used on set as a POC in virtual production environments. So scenes, identical scenes that are are being filmed at disparate locations. That is the trend going forward. A lot of these studios have backgrounds projected on LED screens that are synchronized with the filming camera. So when this camera moves, this background will move in concert with it to ensure that there's that parallax effect and looks real. It's not a static image in the back like they used to do in the old days. But there's a lot of complexities with this when you're doing multiple location shoots. There's lighting, there's set design. Is everything in the right place? Are the actors positioned? Is the camera positioned? Is focal length set the same? So all of that is captured by these devices and that are either mounted on the camera or on rails, constantly scanning the scene. And things like color matching, lighting, and all those things I just mentioned are annotated as part of the filmed, as part of the film that comes from the camera it's mounted on or other sources. And then the models are applied to it. It identifies any sort of issues that might create reshoots, which is the most expensive and time-consuming and logistically difficult thing to do. And so that will get identified nightly, as opposed to however long it takes production crews to get dailies and look through things. They're prioritized by problem, right? As some, let's say, for example, some color matching issues can be resolved by the use of cinematic LUTs. So if their color balance isn't quite right or their lighting is slightly off, there are algorithms, machine learning models that can be applied to that to say, yes, we can use this particular color lookup table to transform this existing shoot into the correct color space for the end film. We're in good shape. Let's go for it. The other thing is, since that's all being done, you can also create these quick clips, whatever the dailies are. And this is something that marketing teams with these productions are looking at leaking out, at some regular interval, whether it's daily or weekly, to say, hey, look at what, is being filmed now. Look what this actor said. Let's have a close up of this actor. Gets tweeted out with a little 10-second clip. They start building some buzz. Okay. Unrelated, but this is this is something I'm also delivering as part of this here shortly. All right, so there is some smoke and mirrors for me to kick some of these events off, but all the fundamental meaty aspects of this are legitimate and working. It's unbelievable. And frankly, most of the stuff that I've done in the past has been so jury rigged and wired together from so many different engineers that, it's just not production ready. This is production ready. Even the experiments I've been doing over the last couple of days. There is a visual UI that I can, essentially help define that data normalization process. You'll see, here's your data sets, how you're going to be processing it, normalizing it. Here is, oh shoot, sorry guys. Here you actually see how fast your algorithms are learning. So again, it's evolving right now. When I go back to the model, I'll be able to look at existing results, refine some of those results, and let it run and chew again. You can see it chewing over here, right? This is it chewing on different models, showing where it succeeded, where it failed, and it actually measures results, whether you're actually making improvements in your prediction capabilities. Knowing how models are performing when they're so interrelated and dependent on each other is very, very important. This is just more workflow. It just gives you a highly visual way to understand how data is flowing, where decisions are being made, what features, is it a person's age? Is it the speed of the drone? Is it, what is, why is that being weighted the way it is? Often you have to guess, just experiment with. This actually gives you visual tools to understand why your model is making the decisions that's being made, and what possible solutions there are. Incredibly powerful. So if anything, I don't know if any of this stuff is very useful that I'm doing. It's useful to me, I guess, but and some people I know. But the reality is, this is an official kick of the tires of this. Is this sustainable? Is this effective? And the answer, in my opinion, is yes. There's no way I could have done what I did here, without the flexibility and maturity of Google Vertex right now. It's just mind blowing. So anyway, hopefully this gives you some. I'm sure there's lots more questions. I'm sure I got some things wrong. I don't know. I'm going to probably clean this up and do more versions, but I'm just tired. I've been working on this all day. So anyway, hopefully this gives some context to further questions or whatever. But shit's real. It's awesome, and can't wait to solve some problems with this. So anyway, thanks for your time. Bye.